Assalamu alaikum, this is me Rabia and 211254 and I am going to explain this code. In the first line DDRB, DDRC and DDRD, we are initializing the port B, C and D. In the next line, we are assigning the some value to the port B. For example, 0x35 and operation will be performed here and the result will be stored in the port B. In the next line, OR operation will be performed in the next line. Uh, uh, XOR operation will be performed and the result will store in the port B. Next, the inversion of 0x55 will be stored in the port B, and at the last, while 1 is showing that this loop will run for the infinite times. Next, we have the Proteus implementation of that code. Here we can see that anything that was stored in the port B, port C, and port D is showing in this implementation. Next, we have another code. In this code, we are initializing the port B and port C, port B for the output and port C for the input. Next, we have the while loop. This while loop will true for always. Um, in this while loop, we can see the if condition. This if condition is defining as if the fifth bit of the pin C is high, then the port B equals to 0xFF. If it is not high, it is low, then the port B equals to 0xAA. This while loop will run for the infinite times until unless this condition becomes false. Next, we have the Proteus implementation of that code. In this Proteus implementation, we can see the output of our required code that is at the port B. Next, we have the another code. In this code, we are using the unsigned character Z. Unsigned characters Z have the size of 8-bit, that can read the 0 to 255 bits. Next, we are initializing the port D for the output. Next, we have the temp variable and 0x02 value is assigned to the temp variable and temp variable have the data type unsigned character. Next, we have the while loop and this while loop is defining at z equals to temp. Now, we will update the value of z and now implemented the switch conditions. If this switch condition will check what is the value of z. If z equals to 0, case 1 case 0 will be implementing, that is port D will be assigned with the 0 value. Next, if the z becomes 1, then our output will be changed according to the condition. Next, we have the Proteus implementation of our code. In this, we can see what is the value of z and what is the output of our code. Next, we have another code. In this code, we first define the two libraries, LED7 and sensor1. Next, in the main code, we can see that we have defined the two ports are DDRB and DDRC. Port B is set as high for the output, and DDRC first bit of the DDRC is set high, is set low for the input. Next, we have the while loop. In this while loop, we can see that if we have if condition, and this if condition is defining as if the first bit of the pin B is high, then the port C, first bit of the port C is said to be high, otherwise the port C is set as low. This loop will turn on infinite times. And next, we have the Proteus implementation, and in this we can see that our LED is blinking. Next, we have another code, and in this code, we are generating three variables: BCD byte 4 and BCD byte W and Z, and all of three variables have unsigned character data type. In the next line, we are defining the port B. In the next line, AND operation will perform between 0x0f and W, and the result will store in the W. Next, in the next line, W will be masked. Fourth bit of the W will be masked, and in the next line, same AND operation will be performed between Z and 0x0f. And finally, the result stored in the BCD byte will be assigned to the port B, and this port B will show the output in the Proteus implementation. Anything that was stored in the BCD binary coded decimal, that will show here. Next, we have another code. In this code, we again define three variables: x, checksum, and my data. My data is an array and it is storing some hexadecimal values. Next, we have defined the DDRD port D for the output. And next we have the for loop. This for loop will run for the 5 times from 0 to 4. In this for loop we have condition checksum equals to checksum plus my data. This checksum will be updated in each iteration. Now we have the in checksum equals to 0, so in the first iteration checksum equals to only my data. Now if condition is defining as if checksum equals to 0, then port D equals to G. Otherwise port D equals to B. Next we have the Proteus implementation, and this Proteus implementation is showing that the all five iteration of the that for loop. Next we have another code. In this code we are again defining the five variables x bin by d1, d2 and d3, and all of these variables have unsigned character data type. Next we are defining the port B, port C and port D, and setting these ports for the output. In the next line 0xfd will be assigned to the bin byte, and then bin byte will be divided by the 10, and this value will be assigned to the x. Similarly, bin byte will take the modulus of by 10, and then this value will assign to the d1. Similarly, x modulus of 10 will be assigned to the d2, and x divided by 10 will be assigned to the d3. And these all d1, d2 and d3 will be assigned to the port B, port C and port D for the output. Next, I will show my Proteus implementation, and in this we can see what is the output of port B, port C and port D. Next, we have another code. In this code, we have defined two variables, that is X and register A. Both variables have data type unsigned characters, and we have assigned the value 0 to the register A. Now, in the next line, port C is masking the pin 1, and the pin 1 is set for the input. Next we have the for loop. In this for loop will run for the 8 times from 0 to 7. In the first line we can see that register A value will be equals to a register, and it is shifted to the right. In the next line the data copied from the cell pin and pasted to the most significant bit of the register A. Next, we have another code. In this code, we have one variable having data type unsigned character and one array having data type of unsigned character. Next, we are defining the port B for the output. Next, we have for loop. In this for loop will run for the 10 times from 0 to 9, and in each iteration, one value will be assigned to the port B, and port B is set for the output. We can see this output for on the port B in the hardware implementation, in the software implementation. Now we can see that anything that was stored in the port B one by one is displaying in this output. Next we have another code similar to the previous one. In this code we have again one array of char data type and the unsigned character Z. Now DDRB port B is again defining for the output, and we have the for loop. This for loop will again run for the 8 times from 0 to 7. We have delay of 50 milliseconds, and then port B equals to minus Z. In this anything that is in the array will assign to the port B. Next, we can see this in the Proteus implementation. When z equals to 0, the first number is shown here, and when z equals to 1, the next number is shown here. Similarly, the output will change for the multiples of time even when the loop is running. Now here is the next code. In the next code we have the defined the port B for the output. Here we have the while loop. In the while loop, we can see the port B equals to port B plus 1. This means that in each iteration, port B will be incremented by 1. Next, we have the 50 milliseconds delay. This is defining as when port B equals to 1, LED 1 will glow, and after 50 milliseconds, the next LED will glow. And here is the output of our code. In the next code, we are defining the port C, port D, and port B for the output. Next, we have defined the temp variable of unsigned character data type. Next, we have the while loop. In the while loop, temp equals to pin C. Anything in the pin C is assigned to the temp. Next, if temp is less than 10, then the port B equals to temp. Otherwise, port B equals to temp. Here is our Proteus implementation, and this shows that when temp is less than 100, then port B is showing our output, and when the temp is greater than 100, then port D is showing the output.